In this video, I'm going to talk about a sequence. All right. Now, a sequence is a set of numbers following each other in a definite order. Okay, so we mean numbers following each other in a definite order. So there is a pattern. Okay. Now let's consider the following numbers here: 2, 5, 8, 11. 2, 5, 8, 11. All right, so now 2 and 5, we can see the difference is 3. 5 and 8 have 3. 8 and 11 we have 3. Now with this we can determine the next terms, okay, or the next numbers here, because there is a pattern, there is an order here in which we can follow. Okay, so we know that when we keep on adding this 3, okay, we will get the number or the required numbers or the required sequence once we keep on adding this 3. Okay, so we can also talk about this: 2, 4, 6, 8. Okay, so 2, 4, the difference is 2. 2, 4, 6, 2, 6, 8, 2. So with this, you can see the next digit is 10, 12, 14, 16, and what have you, because we know that the difference between the numbers here, okay, the difference between the numbers here is 2, 2, 2, 2. Okay, so that's that. Now, you can also be given a fraction to determine. Okay, you can talk about 1 on 2, 1 on 4, then 1 on 16. Okay, so it means you can say 2 squared is 4, 4 squared is 16, and what have you. So the next one will be 1 over 16 squared. As simple as that. So a sequence, just as I said, is a set of numbers following each other in a definite order. So these are all examples of sequence. Okay, now if I write 1, 3, 9, 13, 14, 20. Okay, so if I look at these numbers, there is no definite order here. There is no pattern because 1 and 3 is 2, 3 and 9 is 6. So there is no pattern here, and therefore it will be difficult to determine the next digits here. So these numbers are not sequence. So these numbers are not sequence. So that's the idea of a sequence. Okay. Okay, so let's observe the following. Okay, so if the last term of the sequence is known, it is called finite sequence. So we know the last term here, so this one is called finite sequence. So we can't tell the last, and this one is to infinity, so we call this one infinite sequence. Infinite sequence. Okay, that's that. Okay, a series is formed if the terms of the sequence are connected by the plus or minus sign. So in case you are given a sequence like 2, 4, 6, 8, Okay. Now, before this sequence can be series, unless we connect them with either plus or minus sign. So this one will be series when we put addition sign in between them. Okay, like this. So this one is a series. This one is a sequence. Okay, so look at the arrangement. So we can also talk about 1 on 81, 1 on 27, minus 1 on 9, 1 on 3. So these are all series. So they are connected with either plus or minus sign. That is meant by series. Now we have two types of sequence. Okay, so the first one has to do with arithmetical progression. So we use AP for it as shortcut. So AP is the same as arithmetical progression. So they also call it linear sequence. Linear sequence. Okay. So the next type is called geometrical sequence. So GP is the name, or exponential sequence. Okay, so we take them one by one. All right. So let's start with the arithmetical progression, that is AP. Okay. So AP, arithmetical progression. Okay, so with the AP, it's very simple. Now let's consider the following sequence: 1, 5, 9, and 13. Okay. Now, if I ask you to determine the next digits or the next terms, because this one follow, once it follows a pattern, you can determine the next terms here. Okay, so we know from 1 to 5 is 4. The difference here is 4. 5 to 9, 4. 9 to 13 is 4. Okay. Now, the difference here, okay, 4, 4, 4 here, there is a name for it. Okay. Now, we use D for that. But be very careful here. To find D, that is D is called common difference. Common difference. So it's simply the difference between the second term and the first term, or third term and the second term, or the fourth term and the third term. So this one is called the first term. So we use U1 for it. This one is called second term, third term, then U4 is fourth term. So to find D, that is common difference, is either the second term minus the first term, or the third term minus second term, or the fourth term minus the third term. So this is the same as 5 minus 1, which is 4, or 9 minus 5, which is 4, or 13 minus 9, which is 4. So D, the first term, talk about is common difference, that is D. So it's simply the second term minus the first term, or the third term minus second term, in that order. All right. Now, always the first digit is called the first term. So we use A for that. So A is the same as the first term here. Okay. So the first term here is 1. And the common difference is that. So, all right. So let's consider the following: 2, 5, 8, 11. So what's the first term here? So my first term, that is A, is 2. Then my common difference is simply 5 minus 2, which is 3. So that is that. Okay. Now, we said this one is the same as the first term. Okay. And we use U1 for it. So this one is A. So this one is U2 second term, U3 third term, U4 fourth term. Okay. So if I write A is the same as U1. So don't forget this. Okay, it's very important. Now, once we do understand the meaning of the first term and the common difference, let's go ahead and deduce the formula for AP. Okay, the formula for AP. All right, so we are saying that once we know the first term as and the common difference, we can form a sequence. Now let's assume that the first term is 2 and the common difference is 3. So A is 2. Now once we keep on adding the D, okay, a sequence is being formed. So 2 plus 3 is 5, plus 3 8, plus 3 11, plus 3 14, in that order. Okay, and we are saying that this one is called U1. That is the first term. So we have A here, U2 second term, U3 third term, U4 fourth term, U5, in that order. Okay, so for an AP, each term is obtained by adding a common difference to the preceding term. So each term is obtained by adding the common difference to the preceding term. So once we know the first term and the common difference, the sequence can be formed. Okay, so let's look at how to deduce the formula for an AP. Okay, so before that, the nth term, okay, the nth term is noted by un. Okay, it means that first term is u1, second term is u2, third term is u3, in that order. Okay, now let's deduce the formula for finding AP. Okay, all right, so we said the first term, okay, we said the first term, that is u1, is the same as what? A. So to get the next term, we have to add the common difference. So the second term is A plus the common difference. So what will be the third term? So we have A. Once we add D, I'll get 2D here. So the fourth term, so I'll keep on adding D. So this side will be 3D. But let's observe something here. Okay. Now, when this side is 2, okay, this side is 1. When this side is 1, so we assume that this side is 0. Okay, so we have 0, 1, 2, 3 in that order. So it means that U7, okay, following the the trend here. So if I write U7, this side will be A plus 6D, because this side is reduced by 1. So if this side is 4, this side will be 3. So U7 is A plus 6D. That is the seventh term. Okay. So what will be U20? U20 will be A plus 19D, in that order. So what is the nth term, UN? Looking at the trend here. So UN. So if this side is U1, you have A plus 0D, U2 A plus 1D, U3 A plus 2D. So what will be UN? Okay. So this side will be A plus. So this side will be reduced by 1, and minus 1D. So if this side is 2, to be 2 minus 1. Yeah. So that is the general formula for an AP. Okay. So we have A plus A plus N minus 1D. So remember that A here is the first term. So we have this one as the common difference. All right, as that. So the N here is the number of terms. Okay, so that is that. So in case we're given a sequence and you're asked to find the specific number of terms, okay, just substitute n. So if you are asked to find the 10th term, that will be U10, and this side will be 9. If this side is 10, this side will be 9. U20, this side will be 19, in that order. Okay, so that's that.